Dr. Wang teach math. So I'm Dr. Wang. Welcome to this series lectures about actual exam P1. I hope these lectures can help you to easily pass this exam. So the material for this exam include three parts. One is find some simple probabilities, and then we have one variable distribution and two variable distributions. So for distribution, we have discrete distribution and continuous distribution, right? So we have one variable discrete distribution, one variable continuous distribution, or two variable discrete distribution and two variable continuous distribution. So those are just the topics or materials for this exam. So we will go over those basic materials, and also we will go over some sample problems from P0905 and from uh, education exam P. Okay. Okay. So for probability, the basic idea is split whole into parts. So we can split whole into parts by one factor, or by two factors, or by three factors. So let's check some example. So let's see here. We just in our class we have 12 male and 14 female. So we can split this 20 whole class 26 students into two parts. We have 12 male and 14 female. So we just split this into two parts. Okay. So from here, in our class pick 2, so we have so many ways. So from totally 26, pick 2. And the probability we want to find is both are female. So we just from female pick 2, right? So from female pick 2. Okay. So for this problem, like we pick 4. Okay, pick 4 students. So again, we just use it of okay. So from here, 26 students pick 4. So total way is 26 pick 4. Okay, then we want to find the probability that you get 1 female and 3 male. So let's say the from 1 female, so from 14 female, we need to pick 1. So from here, pick 1. From 12 males, pick 3. So how many such a way? So we say, okay, so from 14, pick 1. And from 12, pick 3. Okay, so sometimes we need to find the value for this uh, binomial coefficient. So we can use this formula. But we also can use this way, like from 10 to 3, how many way? We just, let's say, multiply 3 number from 10, so multiply 3 number. And so denominator also multiply 3 number, but we start from 1, okay? So here, from 9 choose 4, so here we say the 9, so here multiply 4 number from 9. And here we multiply 4 number start from 1. Okay, so this is the way for calculation for those find those numerical numbers. Okay. Okay. So now let's say this is the example. Okay. So we have 10 balls. So we just split 10 ball into 2 parts. Like we have among the 10 ball, we have 4 red one and 6 blue one. So we just split into 2 parts, right? And other one contains, let's see, here contain 16 red one. And the number blue one is unknown. So we just put X blue one. Okay. So the probabilities are from here, pick one. From here, pick one. We want to find that both balls are the same color. Both balls are the same color. So this probability we have two cases. Both are red. Can be like P red. Both of them are red or both of them are blue, right? So both of them are red. So such a probability is so here totally 10, so 4 over 10, right? Pick one, this one is red. And here is 16. The total is 16 plus x. So this is both of them are red one. So blue one, both of them are blue one is 6 over 10. And here's x over 16 plus x. So it is such a probability equal 0.44. So from here, we can solve this equation. We can find the x easily. Okay. So those are problems for split whole into part by one fact. So let's check some example for splitting by two facts. So a simple example is just this. Like in our class, we can split whole people by male, female. So we have 20 male students, 30 female students. So we just split the male, female. We also can split by the grades, right? How many A, how many B, how many C, or D, or A. So we have such a table. So from this table, we can have those kind of probability problem. So find PA. So here A stands for the students get the grade A. So PA is just a percentage for getting A among our class, right? So we say this is just equal to total students. We have 50 students. And how many got A? We say 8, right? Okay, so we also can consider the probability for getting A or the percentage for getting A among male students and female students. So we use this notation. So we say in probability, we call this as a conditional probability. So for male students, totally male students, we have 20 male students, right? So among 20 male students, how many get A? We say 2, right? And similarly, we can find this among female students, what the chance, how many get A? Is 6, right? Okay, so if we split all into parts by two factors, then we can have a conditional probability. We just check. We just say check this part, check that part. Okay. And here we also have this whole probability formula. So this formula says if we want to find so this thing happening among all the people, we can check this part. Those people, saying among those people, what the chance this thing happen. Then check another part, saying for those part of people, what the chance this thing happen. So we can check each part. Okay, so in our previous example, we can say like the chance to get A, we can check male students, and we also can check female students, right? So we can say those part is the probability for getting A from male students, right? So and this part is from female students. Then this part for male students over total. So this is we say such a probability among A students. The chance those students are male students. Okay. So sometimes we will need this formula. Okay. Okay. So to split all by pies by two factors, so we can use a table. So simplest case is like we have like male, female. We have two cases. Or here scholarship, no scholarship. We have also two cases, right? So we can have this simplest table. So to fill out this table, like we know totally 20 for male, 30 for female. For scholarship, we have 20 for scholarship, 28 for scholarship. But in order to fill out the table, we need some more information. So this information can be this. So if we know among male students, 9 have scholarship, then we can fill out this table. Is so we male, female. So we know this. Then we can fill out this table easily, right? So here's 20, so we know this is 11, right? Okay. So for female part, we can fill out. So let's say for condition B, so among female students, so they have scholarship. So we can find this, like among so totally female, so they female. So how many for female get a scholarship? So this is for condition B, right? So we can find this 30% of 30 is 9. So we say nine female got a scholarship. Then use this information, we can fill out this table. And then we also can use this condition like this says among scholarship. So total scholarship is 22. Among scholarship students, 60 people or male student account for 60 percentage, right? So we can find like let's say we just do 22 multiply 0.6. So we see this is 13.2. So we say like there are 13.2 male students got a scholarship. So we can fill out this like for scholarship, totally is 22. Then male is this, right? Then for female, so we can find this like okay, 8.8, right? So because totally is 22, so we can find this. Then we can fill out the table. And also we can use this condition. We say male or female, male, these things, and scholarship or gender and scholarship are independent. Those two things are independent, no relationship. So what independent meanings? Independent meanings in general meanings thus A and B, the probability for A and B equal PA times PB. So here we also can have this like, okay, so male and A's. So this actually is the male students with scholarship, right? So this equal PM multiply PA's. So here PM equal, so this is the percentage for male students. So we have totally 50 students, 20 are male, and scholarship among 50 students, 22 have scholarship, right? So we know this. So we know the probability for P, M, and S. So we can find number of, let's see, number of that's male and scholarship. So equal. We just this probability percentage multiply total. There's a percentage multiply total male students. So male students the 20, right? We have 20 male students. So this number is a double barrel and scholarship. So we can fill out this table, right? So let's say if we for this table, if we fill out the number in one cell, then we can fill out the table. So once we have the table, we can answer any question, right? Okay. Now let's consider this problem. So this problem is just fill out the table, then we can find all those things. So let's say it says here PA. So we have like two factors, A or not A, B or not B. There's A and B, right? So PA equal 0.4, then A bar, not A, is 0.6. And this P A and B is 0.2, so here's 0.2. So we can find this should be 0.2. Okay, right? Okay, so then check this condition. A or B is 0.7. So A or B is A. So A, so this cell here 0.2, 0.2, and plus is B. This is 0.7. So this means here is 0.3. Right? So this because A or B is 0.7. So A or B is 0.2, 0.2, 0.3. So we know this is also 0.3. So 0.5, 0.5. So we fill out this table, right? So with this table, we can find this probability easily. So what is this probability? So this is among B. So among B, the B is 0.5. Among this 0.5, how much for A? So A is 0.2, right? And what is this? A among A, how much for B bar? So among A is 0.4. So among A, how much for B bar, not B, so 0.2, right? And this A and B bar. So A and B bar, this is cell. A and B bar, A, B, B bar, 0.2. Okay. So to split whole by two factors, two parts, or two factors, we also can use this Venn diagram. So here A or not A, B or not B. So we have four cases. So let's say here, uh, we so this condition meanings A or B. Suppose this is A, this is B. So A or B means thus A or B, right? So among A or B, A count for 2 over 3. So this is A. So this part is 2 over 3 for A or B. Okay? And so this B, among B, A count for half. So we can say, okay, so among this B, this A, this part count for half. So this means this and this is the same. So we can put this is X, this part is X, then this is also X. Like B is 2X, then A count for X, right? And also, so totally is, we split totally is 3 and A count for 2. So we can find this part is also same. That's this is X, this X, this X. So A count for 2X, A or B count for 3X, right? So then A and B are independent. So this means P, A and B equal PA times PB. So what is A and B? So A and B is just this part. So P, A and B just X. So we get this information, this equation. X equal, so what is PA? PA just 2X. So we regard the total is 1, right? 2X or 1. What is PB? PB also is 2X. So we have this equation. So solve this equation, we can easily get 1 equal 4X or X equal 1 over X. No, X equal 1 over 4. So this is the probability for A and B. Okay, so split all into parts into by two facts. This is also quite common. Like in our class, we split all into we can split all students by male or female. We can use this like, okay. So male, let's say female, and here total. So we can split this into male, female. So this is male count for female 60%. So we put 60. And so male 40. So totally is 100. Okay. So we also can split by grades. So the grade is A, okay, B, C. Okay. Yeah, okay. So how many A total? So we have such a table. So we just fill out this table by source information we give. Okay. So this is 35 got A. So here 35% of 35 student got A, 40 got B, and 25 got C. Okay, so we still need some more information to fill out this table, right? So it just says And we also know that among female students, so here we just consider female students. Among female, so female we have also totally we have 60, right? Among these female students, 40% got A. So 40% of 60 equal 24, right? So we know here's 24 didn't got A. Then we can find that here should be 11, right? So once we have this fill out the table, maybe if we have more information, we can fill out this, we can fill out this more cells. But the question by now we can answer the question: what is the percentage of getting A among male students? So we find among male students, so we know there's a percentage among male students. Totally we have 40 male students. Among them, 11 got A. So this is the percentage of getting A among male students. Okay. Okay, so for finding probability, so we need to check all the cases, right? So let's say, so for here we have two bag. This bag one we contain 100. Let's see, bag one contain 70 red one, 30 blue one, right? Okay, so the blue bubbles. So for bag two, this is 60 red one and 40 blue one. Okay. So this is like you pick one marble from bag one. So from here, pick one. From here, pick one. And put this one to bag two. Then from bag two, pick one. So what is the probability you get a blue bubble? So we say this probability equal. We just check. Okay, so totally how many bubble in bag two? We say by now we have 101, right? Because 100, we put the one. We just put one bubble from bag one. So we know the denominator. But the numerator is so how many blue ones? So can be, let's say 40 or 41, 40 or 41. We have two cases, 40 or 41. Depends on whether this one is blue one or not blue one. Okay. So we have to consider these two cases. So we just use this formula to check. Okay. So if this one is if this is 40 over 101, this means that one is not the blue one, so red one. So this is red one, such probability is 7 over 100, right? Plus, so if this is 41, we have 41 blue bubbles. So pick one, we get the blue one is thus. But the condition is that when that one is blue one, so that one is blue one is 30 over 100. Okay. Okay. So if we have two factors, we can consider those conditional probability. We can check this part, check that part, right? We have those notation. So we also can have more factors, like 3 factors, 4 factors. But for 3 factors, 4 factors, those problems are too complicated. So usually we will check only some simplest case. Like here we have 3 factor ABC, but each factor we have only 2 levels: A or not A, B or not B, C or not C. So totally we have 8 cases. So for such a problem, we can use the Venn diagram. Okay, so for Venn diagram, we find, okay, suppose we just check this uh, overlap first. So let's check this problem. Suppose like we have 3 kinds of fruit. Strawberry. So suppose this is strawberry, and this is blueberry, and this is and and this is grape. Okay, so we just fill out this part. There's a overlap for the 3. So this is just liked by all. So this number is 6. So put 6 here. So then let's say, so we just go back. 20 like blueberry and grape. So blue and both of them, the blue and grape, so 20. So here's 6. Then so we know that, so we know this is 14, right? So make this 20. And then 17 like S and G. So S and G 17, so this is 11, right? So this is 17. And so the 9 like B and S, so we can put this as 3, right? So just use this way, we can figure out this. So then the 39 like G grape, so we can find this is 39, so here's 20, 31, so I think we can put 8 number here, right? So we can fill out this table, let's see. So here total like B25, so here 20, 23, 25, so there's 2. And 22 like strawberry. So 22, so here I think is already 20, so that's 22. And 4 like outside is 4. So we can, so we fill out this Venn diagram, so we can answer any question. So this is the question, how many kids we solve it? So we just count the total numbers. Okay. Okay. So this is the first topic, is simple probability. So we say finding probability, basic idea is just separate all into parts, right? Okay, so we can stop here.